Alright, now we have this almost exact differential equation, and you can check out my previous video because I found the special integrating factor in terms of y for you guys, right? And we know that secant of y is going to make this become exact. So the deal is, of course, let's go ahead and multiply everything by secant of y, and I'll just put down a big parentheses in blue like this, and then we multiply everything by secant of y, and then just keep track with the computation in our head. All right, here we go. We do this times that. So first we will have 2x times secant of y, right? 2x times that. And next we do secant y times cosine y. But what's secant? Secant is the same as 1 over cosine. So this times that is just 1. That's what we have. This is with dx, and then we add next. This times that. Well, tangent is what? Tangent, when that, well, let me just put it down as x squared secant y tangent y. I'm not going to write this as sine over cosine because I think secant y tangent y works better, right? Because I know what the integral of this is, isn't it? So once again, secant y tangent y, let me just put it down as what it is. Next, we have plus, okay, this is 1 over cosine y. This is cosine squared y, so one of the cosine cancel out. So we just have cosine to the first power y. And then this is parentheses, and then we have the dy equals to, technically I still have to do this times 0. It's 0. Alright, this is guaranteed to be exact. You can check that out. Okay, you can just check it on your own. So here we go. Because now this is exact, we know there's a function, and we call that to be capital F, so that this part represents the partial of f with respect to x. And this part right here represents partial of f with respect to y. Okay? Begin with either one, whichever that you would like. Let me use this one. So right here, I know partial f with respect to x equals to that 2x secant y plus 1. And you see the reason I keep putting down the parentheses, it's because I have the plus 1 afterward. So I want to just emphasize the y is the only thing inside of the secant. Anyways, right here, let's go ahead, integrate both sides with respect to x first. So let's put on dx. So on the left hand side, you will get the function capital F. On the right hand side, x is the variable. We have to integrate 2x, which you get x squared. So let me write it down, x squared. Secant y is a constant, so it stays. So we have secant of y. And 1, the integral of 1 in the x world is just 1, so plus x. We are done with the integration, and usually you put a plus c. But this case, y is considered constant because f is a function in terms of both x and y. So instead of putting down plus c, I'll put down plus g of y. A function in terms of y is a constant in the x world. Okay, so this is how the capital F will look like. Let's go ahead, differentiate both sides to the partial with respect to y, and then match with this. So now, let's go ahead, do the partial of this with respect to y, and then do the same thing right here. So on the left-hand side, we will end up partial of f with respect to y equals to, okay, x squared in the y world is just constant, so let's put that down. The derivative of secant y with respect to y is secant y, this is my c, and then times tangent y. Right, derivative of secant y tangent y, and that's it for this term. The derivative of x with respect to y is just going to be 0, and here we have plus the derivative of this with respect to y is just g prime of y. Okay, now we set this equal to that because this is how partial f with respect to y should be, right? So I will just put this down. X squared secant y tangent y plus cosine of y. This is y. And we see this and that match. That means g prime of y should be this. So we can say g prime of y equals to positive cosine y, and then do the integral both sides with respect to y. On the left-hand side, we just get g of y. On the right-hand side, the derivative of sine give you cosine, right? So the integral of cosine will give you positive sine. This right here is positive sine y. And technically, I put down plus a constant c1. You don't put down a function in terms of x because g is just strictly a function of y only. So c1 right here suffice. So this is pretty much it. At the end, for the final answer, we usually write it down as f of xy equals to the constant. So I will put down all the constant on the right-hand side. Let's put down the function part on the left-hand side. F is all that. So we know this is the first part. So let me write it down. We have x squared secant y, and then plus x. Good. And then g of y, we also found it, which is sine of y. Right, so plus sine of y. And for the c1, I'm just going to ignore it because I'm going to put it on the other side for all the constant. So this is altogether equals to the constant c. So here we have it. This right here is the answer. That's it.